Hi, everyone. Hi, Dr. Cater.
Hey.
So I'm Liat.
Hi, everyone. I'm Shannon.
Hi, everyone. My name is Michelle, and our fourth group member, Sabrina, is unfortunately unable to join us today, but we hope we'll have a wonderful presentation. Next slide, please.
Oh, sorry, one second. Okay.
So our research sought to establish an association between lightning occurrence and cancer incidence. Our advisor, Dr. Cater, is a leading researcher in cold plasma cancer therapy, and he suggested that plasma is comparable to a mini lightning event, hence the inspiration for our project. And many of us recognize that lightning is a bright flash in the sky that occurs during thunderstorms. However, what exactly is lightning on a scientific level? A scientific explanation for the phenomenon of lightning is that it's an electrostatic discharge that occurs naturally when there's an imbalance between the charge of storm clouds and the ground. So storm clouds are negatively charged and the ground is positively charged. And this discharge results in a temporary equalization of charges and the release of a large amount of energy, which produces the bright flash that we know to be as lightning. Next slide, please. Okay, so on the basis of Dr. Cater's research, in which he has found much success in treating cancer with plasma therapy, seeing that we hypothesized that lightning is comparable to plasma therapy, our prediction was that regions with more lightning occurrence should have a lower cancer incidence than regions with higher lightning occurrence. And in addition, we anticipated that lower cancer incidence likely means more longevity. Hence, regions with higher lightning occurrence and lower cancer incidence are likely to have longer life expectancy as a whole.
Okay, so for our research process, in order to support our hypothesis, the continents for which data was gathered were Africa, Asia, North America, and South America. Australia, Europe, and Antarctica were not included in our research process due to the minimal lightning occurrence in those regions. The factors that we took into consideration when analyzing these continents were lightning maps, cancer data, and life expectancy. Next slide, please. Okay, so the first continent we are going to discuss is Africa. And if you look at the map, Central Africa has the highest lightning occurrences as indicated by light pink in the purple map. And light blue indicates less cancer cases on the map that's white and blue. Next slide, please. Okay, so Africa experiences high levels of lightning occurrences, and it is believed that lightning is more likely to strike at areas that are closer to the equator rather than farther from the equator. Central Africa experiences approximately 75 to 150 flashes per kilometer squared per year, which is a significantly higher rate when compared to the northern parts of Africa that experience less than one flash per kilometers squared per year. As seen by the data, Central Africa has the highest rate of lightning occurrences when compared to the rest of the country, both northern and southern parts. In terms of cancer cases, both general cancer cases and skin cancer cases, there appears to be a decreased rate in the central countries in comparison to other regions in Africa, demonstrating a negative correlation between lightning occurrence and cancer incidence. The average life expectancy of people living in Africa is estimated to be around the mid-50s to early 60s, and it is lower than other countries due to countries having socioeconomic differences. Next slide, please.
Okay, so for North America, if you guys take a look at the map to the upper left, we see that like purpley pink region, which also shows increased lightning like in the South/Midwest area. And then if you take a look at the cancer incidence map, you actually see more cancer. And this is general cancer cases. So you actually see a little bit more compared to the West Coast, where we see like the white, which indicates less cancer rates. And then the bottom map is the life expectancy map, which also is lower life expectancy in that region. Oh. So yeah, North America's Midwest and Southern regions also have about 75 to 100 lightning flashes per kilometer squared per year. And this is a map from 1995 to 2013. And it was really interesting because when I first looked at it, it didn't really like coincide with our hypothesis. So I went and I looked at specific types of cancer. And if you look at the, oh, sorry guys, I don't know how to work this. Okay, if you look at these slides, these are all different kinds of cancer. So we have thyroid, brain, liver, esophagus, and melanoma. And you actually do see a trend when you look at this more specific cancer cases, that there is less number of cancer cases in the region that has more lightning, which was really interesting. And when you look at the life expectancy map, I was also kind of confused about why it's like a much less life expectancy in that region. So I did some research, and apparently the South actually is known for having like the lowest life expectancy for many, many different reasons. Apparently in terms of dieting, in terms of healthcare, also smoking is legal in the South in indoor areas, which like 26 other states, that's illegal. So these are all like different variables that could have contributed to lower life expectancy.
So the next continent that we will be discussing is South America. So as we can see, the central regions of South America seem to have the greatest amount of lightning, as well as some scattered regions in the north. Next slide, please. So the lightning hotspot of South America and the world as a whole is Lake Maracaibo, located in Venezuela. And there, lightning can strike up to 28 times per minute with flashes that can be seen from hundreds of miles away. Northern Argentina, along with isolated locations in Colombia, Brazil, and Peru, are the lightning hotspots of South America, besides that region in Venezuela. And the cancer incidence in South America is greatest in Puerto Rico and Uruguay. Based on the map, as we see on the right, it can be observed that northern South America and some regions on the left of South America have decreased cancer occurrence, lower in comparison to other regions within the continent. And those countries include Venezuela, Colombia, Chile, and Bolivia. And this data is in line with our negative correlation hypothesis. And then within South America, Chile has the highest life expectancy, followed by Argentina and Peru. Chile and Peru rank relatively low with respect to cancer incidence. So this also supports our life expectancy hypothesis.
So I'll be presenting Asia, but really this was Sabrina's data. So same thing, if you look at the map here, indicated by the pink, you see the lightning occurrences, which is increased in like these regions, India, some other countries to the east, like southeast. And then when you look at the cancer cases on the bottom, you also see like that lighter color indicates much less cancer cases compared to the rest of Asia. And then in terms of life expectancy, those regions were also pretty average. So Asia experiences also between 75 to 100 lightning flashes per kilometer squared per year. And overall, Asia has lower cancer incidence rates compared to other like developed countries. And Sri Lanka and India have fewer than 90 cases per 100,000 people, which is what you see in that map, why it's such a light color. And when compared to other countries, Asia appears to have average life expectancy values in India and Sri Lanka, where there's the fewest cancer and the highest amount of lightning. The life expectancies were about 70 and 78.
So some obstacles were encountered when we were conducting our research. Primarily, recent data was not available for certain nations. Africa and South America, for instance, had largely underreported cancer statistics. In addition, available lightning data was localized to cities, whereas cancer data was represented for whole countries, making it difficult to conduct analysis within countries.
So for the outtakes, our conclusions was that there's an intermediate negative correlation between lightning occurrences and cancer incidences. We can't really say for sure since we haven't like done a statistical test, but just purely like observational, that's what we found. And life expectancy appears to be greater in regions with greater lightning for some of the continents that we discussed.
And we do have some future directions, and we plan to continue working on our research beyond this presentation. And some of the directions for the future include conducting that statistical analysis that Liat mentioned, so that we can get perhaps an R coefficient or some sort of definitive numerical data to support our findings. In addition, we are going to try to assess various types of cancer rather than global cancer cases. As Liat mentioned, there was a distinct trend in North America with specific cancer types and not necessarily cancer as a whole throughout the continent. And finally, we are going to try to look for more localized data. Much of our data came from countries as a whole, and we had difficulties finding data for localized cities, whereas lightning data was localized to cities. So we were going to try to find more numerical data to support that.
These are just our references in case anyone's interested.
So we would like to thank Dr. Cater, our advisor, for all of his input and direction. We really appreciate all the insight you have given us. We would like to thank Rabbi Hanfling for making this opportunity possible during this challenging time for all of us. It was really an amazing opportunity to be able to conduct research online, so we really appreciate that. We would like to also thank Nurse Sue for her continued support, emailing us, checking in with us, making sure we were always on top of everything. We would also like to thank Dr. Friedman for his input and all of his presentations. We really appreciate that. And we would also like to thank all the guest speakers who took the time out of their schedules to come speak to us and spread their knowledge. We'd also like to thank the JMED cohort for being an exceptionally warm and welcoming community, and also everyone else working behind the scenes. Thank you so much.